Hello, we are Tower Engineering and this is our project Ignite the Night. When we started this project, we get the idea of if cities are becoming smart, lighting should be as well.
More about that, the problems we saw would occur in the Queenston development is ensuring that all roads and walkways are safely lit and making nighttime settings more accessible for everyone. This includes those who are visually, physically, or mentally disabled. We must also find a way to reduce energy costs as a large portion, about 15 to 40% of some cities' total energy is spent on street lighting. Finally, we must adhere to the dark sky compliant, which is a point made on the development plan. This compliant calls for sites to not be over-illuminated, streetlights to direct light downwards to minimize light pollution and glare. Then the question essentially becomes, how can we effectively use light up streets and walkways while reducing energy use, meeting accessibility standards, and adhering to the dark sky compliant? The solution that we found solved some of these problems was the Apollo street light by gas lighting. It has different sizes which ensure flexible lighting. It also has a limited dimming schedule, which based on the time of day or month dims to conserve energy. The light head also features an optical system which adjusts the light level of the lamp to its surrounding environment and also conserves some energy. This design allows for easy replacement of the LED panels and light to be directed downwards, which limits glare.
Here's a solution. Our solution will look to solve more of the previously mentioned problems by first having 2 solar panels combining for 300 watts to limit the use of energy from the local grid. The streetlight will also be equipped with a City Sense Plus motion sensor by Twilight, which detects the movement of vehicles and pedestrians to adjust light to optimal levels. This means that when the streets are empty, the streetlights will be working on low power or around 20 to 40%, drastically reducing energy consumption. This sensor communicates to the sensors in neighboring streetlights via a mesh network to activate or brighten for a passerby. Furthermore, the City Sense Plus sensors can obtain data such as energy consumption, maintenance needs, and local occupancy levels, which can be recorded and mapped to aid city officials. Here's a demonstration of how the mesh system will work. As a car moves, the sensor on every given streetlight detects it and triggers the neighboring lights to brighten, and once the car passes a light, the sensor detects it and dims its lights. This essentially creates the concept of light on demand. When there's more than one vehicle on the street, the network and sensor will take into account the distance in between the car and either work full power or create light bubbles around each car. Just like the Apollo, there'll be many variants of our lamp. The one we have designed is an 8-module version with 96 Luxion M series LED chips for main roads. LEDs were chosen specifically as they are more energy efficient and have less glare, especially when added with the added frosted glass. As you can see, the design will direct light downwards, and the height of the pole will disperse light effectively. And to solve the problem of accessibility and safety, these streetlights will be equipped with mini projectors to highlight paths on demand in bright, contrasting colors for the visually impaired to safely cross. Compared to the Apollo streetlight, our streetlight obtains energy from the local grid and 2 solar panels. Since the LED wattage of both streetlights are the same, the energy consumption per day will also be the same. However, our solution will be obtaining 0.545 kilowatt hours from its solar panels based on the location of the development. Based on the current rates, we found that the both lights will have the same cost in terms of demand for energy, but our solution experiences many cuts due to the solar panels and mesh network, which reduces the cost per year to $18.15. This is because the majority of the time, many streetlights will be remaining dim and thus use less energy. More exactly, 50 to 80% less, as found by Twilight. Our solutions also create brighter light due to the high power Luxion M series LED chips. Finally, our light shade is warm, around 3,500 Kelvin, which adheres to the dark sky compliant. In terms of the practicality and feasibility, due to the LED chips and load time working at full power, our streetlight can last several decades, unlike the current sodium vapor lights. The completely separate sensor and solar panel systems allow for low maintenance as well as easy replacement of parts. Finally, much of the technologies used within the light are already made and can be bought, like the Luxion LED chips, the City Sense Plus sensor, and the solar panels.
I'll be talking about how important the streetlight will be for society and the environment. First of all, the use of the mini projectors and its overall design allows it to be aesthetically pleasing and allows a more vibrant nightlife. Furthermore, the curved head design will lower glare, which reduces eye strain and facilitates driving. Adding on, the saved expenses can be used for other facilities. Also, there will be reduced light and air pollution due to the use of LED light and mesh system. Therefore, we will be less dependent on greenhouse gases for energy. Finally, the newly incorporated mesh system and the sensor will help limit the fluctuation of the natural light cycles of the local species. As you can see, there are several advantages for using this streetlight.
Thank you for watching and thank you for this opportunity.